Environmental stress cracking is responsible for more than 25% of plastic part failures. If you are a manufacturer who joins plastic structures that will endure stress, you probably know about it. In this video, we'll explain environmental stress cracking and help you understand what you can do to reduce it. What is environmental stress cracking? To understand how environmental stress cracking, or ESC, occurs, we first need to dig into the chemistry of plastics. All plastics are polymers. A polymer consists of hundreds to millions of monomers that are interlinked together in structures, called chains. We talked extensively about polymer chains in adhesives in a series of videos you can find below. It is important to understand that polymer chains are not packed like atoms and can vibrate, rotate, and undergo molecular motion. So when a plastic is under stress, the induced force travels along the polymer chains, causing them to creep towards the pool where that force is being applied. The molecules along the polymer chain then have to strain to keep in contact with each other. That's what we call creep rupture. Then the molecules along the chain will deform and eventually separate, causing the stress cracking to happen. Environmental factors like chemical exposure or temperature variations can significantly speed up the process. Potentially, any plastic under stress could result in environmental stress cracking taking place. However, amorphous plastics like polycarbonate, ABS, and PMMA are the most prone to environmental stress cracking, as they cannot resist chemicals so easily. Does the joining method matter? As we just mentioned, environmental factors can speed up the process, but stresses and tensions will cause the stress cracking to take place. That makes the joining method of plastics very important. So let's take a caravan, for example. When the manufacturer joins a plastic roof to the body of a caravan, the plastic component will be molded or shaped, which can already put the polymer chains under stress. Then it will often need to flex to fit in place, which puts it under stress even more. You now need to think of a joining method for that plastic part that is already under stress. There are typically two options at this stage: mechanical fasteners and adhesives. You can learn more about the specifications of each method in one of our previous videos, so make sure to check our channel and don't forget to subscribe. Regarding stress cracking, both mechanical fasteners and adhesives could actually make your issue worse. That said, a mechanical fastener will consistently increase the likelihood of environmental stress cracking because it is a small focal point that focuses the stress on one specific area. Adhesives, on the other hand, will ease that stress by spreading it across a much wider area, but they do pose a different sort of risk. As we mentioned earlier, chemicals can sometimes speed up the stress cracking process. Some sealants and adhesives contain aggressive chemicals and often require cleaners like isopropyl alcohol, which combined can significantly speed up the stress cracking process. If this combination of chemicals is applied on a plastic part that is already under significant stress, it doesn't take long for cracks to appear. How much of an effect have chemicals on stress cracking? To demonstrate the effect of chemicals on plastics under stress, we conducted our own experiment. We used 3 pieces of polycarbonate. The first piece was put under stress, but with no chemicals. The second piece just had a chemical put on the surface, and the third piece was put under strain with a chemical on the surface. As you can see, piece number 3, which was under stress and had a chemical agent on the surface, experienced the most noticeable stress cracking. Incidentally, it took less than a minute for this to happen. However, the first and second strip of polycarbonate did not experience any form of stress cracking, even though number 1 was under the same amount of stress and number 2 had the same amount and type of chemical as number 3. This experiment gave us 2 main findings. Firstly, the combination of stress and aggressive chemicals will cause stress cracking to occur very quickly. Secondly, when the stressed plastic part has no chemical or environmental factor, it can take much longer for the cracks to appear. What can you do to help prevent environmental stress cracking? If mechanical fasteners and adhesives can speed up the environmental stress cracking process, it may seem like there is no solution regarding joining methods. There are things you could consider to help prevent the threat of ESC from taking place. Here are the top 3 recommendations. Reduce stress on your plastic. Obviously, this is easier said than done, but the more stress you can reduce, the more the threat will decrease. Where possible, avoid using mechanical fasteners and use chemicals that have been tested and are not likely to increase the chance of ESC taking place. Do not use IPA cleaners. As mentioned earlier, these are very likely to attack plastics under stress and cause ESC. Heptane-based cleaners do not present this same problem, but they are potentially hazardous and some companies are hesitant to use them. Acetone cleaners are also aggressive cleaners that will attack plastics under stress. You can reduce the risk of stress cracking through testing. There are several methods available to test whether the chemical is likely to attack the plastic under stress. You can find them in our ebook that you can download with the link below. If the prospect of environmental stress cracking is still a concern to you, you can reach out to one of our experts. They will help you through your particular situation and provide advice on the next steps. Thank you for watching, and if you want to learn more about anything related to adhesives, just subscribe to our channel.